welcome to the first CMIP analysis platform tutorial. Let me put this high up a little better. I just raised it. You lost the signal. Okay, I'll just talk. Thank you very much for coming here and participating in this. Because it's the first one, I'm sure there will be glitches, or maybe it's not quite the right format, or maybe not quite the right selection of lectures or something. So please give us feedback. It would be really, really nice. We might send out a survey at the end, but more than a survey, just please send us feedback. And positive is great, but as long as it's useful, go ahead. And I'm Jean-François Lamarque. I'm the CESM chief scientist, so trying to get the climate model that we have here is kind of centralized here, but built by the community moving forward. I will escape during Jerry's talk because I have a meeting that we're running every Tuesday, but then I'll be back after the break. In any case, so before we get started, I think Barbara has a few items, logistical items, that she would like to mention.
Barbara Ballard, we've been emailing back and forth for about a month. This is a small meeting, otherwise you would have been hearing from me for months. So consider yourself lucky. So I want to talk about a couple things that are in your packet. The first of which is your travel voucher. Looks like this. If you're receiving travel support to attend this meeting, you should have one of these in your packet. Sign here on the yellow highlight and put it in this tray that's out here on the desk. I'm hoping to get your checks to you tomorrow, but I must have this signed before you get your check. The next thing is your YubiKey. The majority of the people in this group already have a YubiKey, so you should have brought that with you. If not, you could be having some difficulty doing the practical sessions this afternoon. So in your packet is an acknowledgement form that looks like this. You don't need to sign this, but read over it. When we have the break this morning, I will be back out here at the table. For those of you who are getting your YubiKey today, you need to sign for that, and this just tells you what you're signing for. For those getting their YubiKey today, on your agenda in the upper right-hand corner is your PIN number. You will need that to use your YubiKey. If you get a YubiKey from me today, it's in the little manila envelope in your packet. You will need to return that when you leave on Thursday. It's just the way they run things downstairs. So I hope that you enjoy your time here this week, and I'll be seeing you throughout the week a little bit here and there to give you some money, get signatures, all those kinds of things. So enjoy your time. We're happy to have you here. Thanks.
Thank you.
All right, so I'm just going to give a general introduction before we get started. And first of all, I'd like to acknowledge the fact that this would not be possible. The funding of your travel and all expenses and our ability of inviting speakers without the funding by NSF. So and I'd like also to acknowledge that this is clearly not my thing, and this has relied on the help of many people. And I'd like to highlight Dorrit, who's right here in the front. Oh, well, and she's been instrumental in organizing all the statistical method session tomorrow. And then also Ben Sanderson is really helpful in getting this tutorial organized and planned. And then Davide Del Vento, who will be talking this afternoon, has been helping getting data sets ready for all the labs that you guys are going to be having. And then, of course, Barbara for logistical support, BJ Smith, I don't think he will be part of this, for the web support, and also all the lecturers. And everyone is extremely busy, and I'm very pleased that they were able to come, take some time off their schedule and come here. I think we have a tremendous level of expertise that we were able to gather in terms of the speakers. And so I think this is going to be, in my view, a very exciting tutorial. An addendum to the agenda is it's something we didn't really want to advertise too broadly. So it's that there will be a gathering of everyone at a place that's called Under the Sun. So if you've been to Boulder before, you know exactly where that is. If you don't, it's basically at the bottom of this hill. And then there's a big shopping center right there at the bottom. It's in the eastern portion of the shopping center. Mountains are on the west, that direction. And so we will be gathering there. The shuttle will leave from that location, right? So if you want to catch the shuttle, you'll have to gather there, whether you're going or not. There will be two shuttles, one at 6:45, one at 7:15. But you can also just catch the shuttle. We have a regular shuttle, and we'll stop there. And so you can just catch the shuttle here if you don't want to go and have a beer and food. But you can just go and stay here and work and meet us there and then catch the shuttle to go to your hotel. So you will have to pay for your own food and drink because this is NSF funding. There are all sorts of regulations. It's absolutely impossible to pay for anyone's food, which is why it was a lot easier to pay for your per diem. That's why there is no coffee or anything here, because we have a cafeteria. So if you want coffee, which reminds me, the cafeteria is you weave your way this way. So you go out, turn right, turn left, turn right. Right, left, right. And then you have coffee that you can just pay for. Restrooms. Go down, men on the left, women right, then left. All right, so after that, I think I've got. And then it would be nice to know, to let us know, I'll let Barbara know, if you're going to come, so that we can call in the morning of Wednesday. Yeah. Okay. So you don't. So for the people hiking, you'll have 2 extra miles going downhill before you make it to the pub. All right. So now that we've covered all the important topics, let me just talk about why do we have such a thing as the CMIP analysis platform. And so the just overall, the current holdings on the Earth System Grid Federation, which is the collection of nodes around the world where the CMIP data resides. So not everything resides locally, but you can access the data on the Earth System Grid. And the holdings are, give or take, a few hundred terabytes, 2 petabytes, which is a lot. And yet, thousands of papers have been written. And if you look at the CMIP 5 page, there's over 1,200 references listed there. And so all of those have required people all the authors, to spend time downloading the data, which is not a trivial task, and acquire sufficient disk space to hold the data of interest. And no one that I know of has enough money to buy 2 petabytes of data, Or that would actually probably not be a very good way of spending your NSF funding. If everyone around the room is spending disk for hundreds of terabytes or petabytes, it's not very efficient. And it's likely, in my view, that some science that we could do has not been done because we don't have at our fingertips all the data or most of the data, or we've been able to do everything that we want to do with what we have and having a limited storage. But if you have something that's close to the limit of this CMIP, then there are questions that you can ask that you haven't been able to ask before. And I might not give great answers, but you can at least ask the question. And I really feel that at the level now and the next step is that there are questions that we should try to answer. And this is basically why the CMIP analysis platform came up as an idea about a year and a half ago. And it's like, okay, let's do that. Let's build something that will provide researchers with both the disk space and the computing power to perform analysis. So we have about 500 terabytes of disk available. It's not 2 petabytes, so we cannot put all of CMIP5 right there. But quarter is pretty good. And the computing power, which is why during the lab exercises, we want you to just get started on running scripts on Geyser. Geyser is the analysis machine that we have here that is directly attached to all those disks. And so people can just run all the scripts, and you'll have more information about that in the afternoon, about all the softwares that are available. And we have most of the software available unless they're very exotic. And then even those we might be able to provide help on getting them installed. And then one thing to keep in mind, CMIP6, I don't know if people are familiar here, I will give a talk at the very end on what CMIP6 is and where this is going. But this is in the phase now where simulations are about to start. People are getting ready with their models to at least perform some of the initial simulations. And so we're really expecting things to come in over the next few years with probably, and most likely, with more data than CMIP5. Right? There's going to be more models. It's very likely. Going to be higher resolution. A lot of models are thinking of running maybe twice as high resolution as last time. More Ensemble members. All sorts of requests of data fields are going to be more present. So the idea that you can do the science that you want to do might become more and more difficult next time. And so some of the limitations are going to be even more present. So we think at CMIP6 will be even more, that such analysis platform will be even more useful in CMIP6. So what, as a starting point, the most typical example that we have of multi-model analysis is the IPCC AR5 type plots. Right? So this is where you end up, and you probably don't see it, but there is like stippling here. So the idea of this workshop is to kind of go a little bit through this, but kind of focus on how do we go from all models having the same forcings, or at least so we think, to just a variety of responses, and then some really funny little glitches here. Global surface temperature goes up, and then in 2100 it goes down. So how does that happen? And what is this color scale? What is this range? What does it mean? How do you get there? And then from those simulations, then you go to more local, regional distributions, trying to understand and trying to generate, at the very least, a plot like this. So this would be like the ground level of starting is of what this tutorial will give you is this. But actually, we want to give you a lot more than that because there are lots of caveats behind this and this type of analysis. And so the tutorial will have a range of talks that will give you both basic, not like elementary, but basic analysis, but also much more advanced methods and way of looking at the data. And so what we've tried to do is to go kind of sequentially on, first of all, just spending the first day on explaining what this platform is, how does it work, and so I don't know how many people here have actually tried to use it in the first place, but if you haven't, then this will tell you exactly what you can do and what's going to happen or not happen. And then once you have the data here locally, and then we'd like to work on statistical methods, right, to get you to get the basic, the tools that you need to do multi-model analysis. And then we thought a good way to go into that is then to go to scientific studies that are using those statistical methods, both on mean fields and extremes. I think it's really important to look at extremes, especially in this. So we try to do a mix of lectures and labs, and I hope this will be quite successful. And so what we really would like is provide example of best practices. And I cannot tell you how many papers I've seen where people make a modification to a model, run the model for 1 year, look at the difference and say, aha, this is so important. Look, the differences are huge. This is terrible, but you still see it. So this is, in this way of thinking, we have to really think about things very differently. Some of the next steps that I'd like to highlight is this is also a way for you to be aware of some of the next steps that you could take. If CMIP 5 is not enough, right? It's a good start. But if that's not enough, or you want to look at things differently, we have, at least here internally at NCAR, we have generated single model ensembles, large ensembles. Like we have done a 40 plus, I keep losing track of how many we have, but 40 plus ensemble members. And I will spend a minute here on explaining this. And a medium ensemble, and a last millennium ensemble, and looking at fixed aerosols. So we have additional data sets. Those are residing on the same disks here locally as the CMIP analysis platform. There's no difference, just a different directory. So that at your fingertips, you will actually have more than just the CMIP 5 analysis. So just to give you an example, the large ensemble is a single run, a long control, and you will learn to appreciate long controls. A single member going from 1850 to 1920, we usually do our control for 1850 conditions. In 1920, stop the model, put a big butterfly in a model, 10 to the minus 14 K perturbation in temperature in the atmosphere, right? It's pretty small. And then keep on going. So you just change the initial conditions, and nothing else changes. And then you let the model go from 1920 until this plot is for 2080. It actually goes to 2100. So it's like a round-off error. Last bit. And what does it do? Well, if you start here, January 1st, this is the global mean temperature. And so here, this is the global mean temperature. The black line is the mean, and the gray lines are those ensemble members. So not very different. Right? You don't expect very different because there's not that much energy. There's basically no energy, no difference in the energy input into the system. But at the same time, if you look at the very initial steps, it's like weather forecast, right? But this is the global mean temperature. So at first, you don't really see that much difference because the global mean temperature is not going to change that much. If you looked at weather fronts and regional patterns, you'd see much more difference. But then after about 20 days, then the different solutions start to diverge. So this is noise in the system. And then, but this is like 2 months. What does it do for longer time scales? And this is where it becomes really interesting. Is if you look at this trend over 20 plus years of the wintertime surface temperature, and this is just 9 ensemble members that are picked out of the collection, and you just look at the variability over even just a region, say Northwest US right here, and try to look. And this is the trend over 24 years of the surface, wintertime surface temperature from initial conditions that were changed 60 years prior. So you have to understand what does statistical significance of a difference really means when you start using those models. And this will give you an idea of what the noise in the system is. You have to understand the noise to really understand the statistical significance. And this is kind of a totally off topic, but this is to me a perfect example of this in the real world, people doing this analysis. So there is this paper by Joe Farman, 1977, observing trends in ozone, total ozone column over Antarctica. And so they started in the International Geophysical Year, 1958. And then the paper is like a very short paper, like 4 pages. They really spend most of their time trying to explain why it's going up over this like 15-year period, trying to explain some interesting chemistry and all this stuff. And then, it's like another paper, and I don't think I got that many citations. And then 8 years later, Joe Farman became really famous for writing this second paper, where this period was just noise. It wasn't really worth spending all that time because the forest system was actually a really strong trend in the meantime, forced by the CFCs. And the CFCs were there already, right? But you couldn't really see it because there was enough variability in the system. So it's really dangerous to spend your time looking at a very small record, and looking at a long record of a forest system will give you a much more valid piece of information. And you get really famous for this paper, which ended up giving people who explained why this was going on the Nobel Prize of Chemistry. So basically, so I wanted just to give you an overview, remind people of the existence of these, and there's a lot more data that you could use. And so part of this tutorial is also to demonstrate the usefulness of the analysis platform. So feedback, please, but also use it and put it under pressure. Let's try to see what works, what doesn't. because we got funding for NSF, as always. This is for short-lived, a few years, and we have to see how long it's going to be, and if we want to make the switch to something much bigger for CMIP 6, then we'll have to justify, and it actually helps. So we'll rely on you to use it, tell your friends, family, pets, that there is such great thing to use, and then write papers and say, this was done only because we had it. Not quite, but if you'd really make this also a big community effort, then I think there's going to be a lot more people who could take advantage, and then hopefully we can get some great science done after this. And with that, I'll just finish, and any questions? Carl.